Well, good afternoon. I want to welcome everyone to today's webinar. We're going to be looking at the 2018 International Energy Conservation Code, specifically the commercial mechanical provisions, along with some of the associated provisions in the International Building Code, as well as the International Mechanical Code. I'm Ryan Siegel. I'm here with Robert Nemeth, here at the Smart Energy Design Assistance Center at the University of Illinois. I do want to go over a few housekeeping items here. Today's webinar is being recorded, and the recording as well as a PDF will be made available on the Smart Energy Design Assistance Center's website. The controls for today's webinar should be able to be found if you hover towards the top or bottom of your screen. If you do have questions as we're going through the webinar, please feel free to use the question box, and we will try to answer those as appropriate, either during the webinar, at the end of the webinar, or for some questions we may have to follow up after the webinar for it. Following the webinar, there will be a certificate of completion along with a survey that will be emailed out to you. And I want to thank you for joining us for today's webinar. So a little bit about who we are. We are at the University of Illinois at Urbana-Champaign. We are a public-private partnership with 360 Energy Group, housed up in the city of Chicago. And our goal here at SEDAC is to reduce the energy footprint of Illinois. So that includes both our governmental footprint as well as the footprint of the private sector buildings across the state of Illinois here as well. So today's webinar is being brought to you by the Illinois Environmental Protection Agency's Office of Energy. SEDAC has collaborated with the IEPA to provide code training as well as technical assistance for the Illinois Energy Conservation Code. So as far as what some things that we offer, we do offer a technical support line, so that can be for building owners, energy code officials, design professionals, or anyone else who may have a question related to the Illinois Energy Code. So that technical support line is an 800 number, or if you prefer, an email address, energycode@sedac.org. We do have several online resources at our website, which is provided here on screen, sedac.org/energy-code. We do offer several workshops throughout the year on varying topics. We do have a couple of workshops coming up that I'll talk more about at the end. Those workshops are coming up next week, April 30th. We also do have a collection of webinars. You will be able to find several past webinars also available on our website, such as today's webinar. For those who are looking for some additional training but may not have resources to travel, we do have online training modules. There is a new set of modules coming soon. The existing modules are covering the 2015 based Illinois Energy Code, and the new modules coming soon will be on the 2018 Illinois Energy Conservation Code. One question that we have been fielding frequently has been what the adoption date of the Illinois Energy Conservation Code 2018 version is. To the best information that we have at this time, it is going to be June 1st of this year. So in just over a month, we are going to be moving from the 2015 IECC to the 2018 IECC as the basis of the Illinois Energy Conservation Code. We do keep our website up to date with the latest information, so as things develop, please make sure you keep an eye on our website, as well as our monthly newsletter that goes out. So I mentioned earlier our website, so if you go to SEDAC.org, in the upper right corner is Energy Code Training, and that will provide you links to all our various resources, past workshops, webinars, and online training sessions. So one benefit that the International Code Council does provide is they do provide free access to their codes. They're not printable or selectable, the free versions. However, they are searchable, so you can use the search function to find a specific keyword, and it'll help you scroll through their web versions of the documents rather easily. So we do have the links provided here on the screen to the three appropriate codes for today's webinar: the 2018 International Energy Conservation Code, the 2018 International Building Code, and the 2018 International Mechanical Codes. So the International Code Council does have several different model codes that they produce, and so they are known collectively as the I codes. And with those, they cover several different aspects. They include several such as the mechanical code, building code, fire code, fuel gas code, and existing buildings code. And we do note here that the International Mechanical Code is for both new and existing buildings, with the exception of those buildings that fall within the International Residential Code, as the International Residential Code, or the IRC, has provisions related to the mechanicals. As far as terminology used in the code, there are some terms used as far as when you have to use which provisions. Prescriptive provisions are a set of provisions, more like a grocery list, where you have to meet each individual. If you meet each individual provision, then you are in a code. Then you are in code compliance, and they have to be met individually. And that is a prescriptive path as opposed to a performance path. Mandatory provisions are required to be followed regardless of if you are using the prescriptive path or a performance path. A performance path would be a building energy model looking at building energy consumption and cost relative to a baseline energy building. So, as we transition over into talking about the codes, I want to learn a little bit more about those people that we have here in our audience today. So we'll have a poll question here for you to answer regarding what your primary role is. Looking to see, well, do we have architects, engineers, code officials, contractors, or some others? Give you a moment here. Okay, looks like the majority of our people here in attendance today are engineers with some code officials and architects. So that's good for us to know our audience as we're going through our presentation here. And with that, I'll go ahead and turn it over to Robert.
It's ringing. It's ringing in my. Something's not right. Okay. Good afternoon, ladies and gentlemen. I like starting basic. So as you can see, the IECC has got 6 different chapters. And we're going to be looking at chapter number 4, energy efficiency requirements. And you can see chapter 4 is broken into 8 different sections. C403 and 404 are the ones we're going to be looking at, mostly C403 building mechanical systems. So Chapter 4, the commercial energy efficiency, C403 building mechanical systems, there have been a lot of changes made to that chapter. There's been renumbering and retitling and rewording of certain sections. There's been additions to that C403 and a lot of changes and modifications of text. And you know, as we make our buildings more energy efficient, these codes are just going to continue to evolve and mature. So in the 2015 version of the IECC, there were several provisions that were mandatory as C403.2, provisions applicable to all mechanical systems. It stated was mandatory and stated that the building heating, cooling, and ventilation systems must comply with C403.2.1 through C403.2.16. This could lead to people overlooking that these provisions were mandatory. Therefore, in the 2018 version, they call out that each provision is mandatory. And just this morning, we noticed that even in the new code, some of these, the IECC has failed to call out as mandatory. Nearly all the provisions in the building mechanical system section of the IECC are mandatory because of C403.2. It encompasses C403.3 through C403.12 as mandatory. Similarly, all provisions in the service water heating sections are mandatory. So most of that section, or a large part of that section, is mandatory. So you can see some of it's just a simple rewording. Here in the 2015 IECC C403.2 the title was Provisions Applicable to All Mechanical Systems. And it's been reworded to 2018 IECC C403.2 System Design. So just a simple rewording, really. The C403.2, the system design, has got 2 sections under it, C403.2.1 and C403.2.2, zone isolation required. It was formerly C403.2.4.4, which is buried further deeper in the code. And the text has remained the same. It's just they're trying to, it makes sense to move some of these sections around. So the text has not changed, but they've just relocated certain sections of the code. And similarly with the ventilation portion, they put it under C403.2. So no really changes other than where certain sections are located in the code. So C403.3 changed from 2015 to 2018. You can see in the 2015, the C403.3 was economizers. that were prescriptive. Now at the bottom of that page that you're looking at, in the 2018, the IECC, it's C403.5. So they've pushed economizers back further into the code where it was a more appropriate location for economizers. And now in the 2018 IECC C403.3, it states that heating and cooling equipment efficiencies, and this is new text, are mandatory. They were mandatory before, but the text is new. Heating and cooling equipment installed in the mechanical system shall be sized in accordance with sections C403.3.1 and should not be less efficient than the use of energy than as specified in section 403.3.2. So once again, some of this is new text in the code. So the C403.3.1 equipment sizing. The old wording was the output capacity of heating and cooling equipment shall not be greater than the loads calculated in accordance with section 403.2.1. It's been reworded to the output capacity of heating and cooling equipment shall not be greater than that of the smallest available equipment size that exceeds the loads calculated in accordance with section C403.1.1, and then goes on to say some more. This minor change provides a needed flexibility, as previously one would require to undersize equipment. For example, if a 95 kBTU is a design load, one could not install a 100 kBTU furnace, even if there was no 95 kBTU furnace available. This would mean that the furnace couldn't keep up when design conditions occur. So this is a great improvement in the code with some simple rewording. The 2018 IECC 403.3.2 HVAC equipment performance requirements, which are mandatory. This new wording simplifies wording from the 2015 IECC C403.2.3, and note that the 2015 IECC 403.2.3 is now CO 403.3.2 in 2018 IECC. Gosh, if I was dyslexic, this would give me even more gray hair than I have now with this renumbering. So the new wording, equipment shall meet the minimum efficiency requirements of tables C403.3.2, table 1 through table 9 when tested and rated in accordance with the rest of that sentence. So what this does is it really does reference the efficiency tables have been simplified. Instead of calling out each table individually, first through the last table are called out. So it's just a rewording that simplifies the presentation of the same information that was in the 2015 IECC.
As far as the 2018 International Mechanical Code, it's similarly broken into several chapters. I've skipped over the first two, which is just the administration and definitions. As you can see, several of these provisions do relate back to the mechanical or likely associated with the mechanical systems that have been designed for the IECC. And so some of those would definitely be things such as the ventilation systems, exhaust systems, combustion air, and ductwork. So several of these are very closely associated, and the codes have really tried to do a better job as far as rather than redefining and re-specifying requirements, to make references back and forth between the codes. Now, understanding that the various building codes are jurisdiction specific rather than on a statewide basis, such as the International Energy Conservation Code, which is adopted statewide. your local jurisdiction may not be on the same international mechanical code, or may even use a different code than the international mechanical code for their local jurisdiction codes. Now, something that we are going to be talking throughout here today is looking at the 2018 version of the mechanical code. Your local jurisdiction may be on a very different one, but understanding where the direction that codes are moving towards, so that could even be something where you could provide some additional value to a client by perhaps offering to be compliant with a more modern version of the code, assuming that your local jurisdiction is okay with using that. Most jurisdictions that we have been running into, they are generally very open to the idea of allowing for a more modern version to be used as a basis of a code. So as far as energy utilization of equipment, the mechanical code calls out that, you know, we are looking to design and install HVAC equipment for efficient utilization of energy in accordance with the IECC. Proper sizing of equipment is very important to proper function of equipment, as improperly sized equipment frequently is less efficient and likely less effective. One example of this could be an oversized air conditioner that would not be able to properly dehumidify a space. And if I have high humidity, that can lead to mold and indoor air quality, as well as comfort issues leading up to this. We'll talk about this a couple of times about, you know, proper sizing of equipment, as that seems to be very important, particularly in the mechanical code. The mechanical code also has prohibited locations for fuel-fired appliances and where they can get their combustion air. Here noting that combustion air for fuel-fired appliances cannot be from sleeping rooms, bathrooms, toilet rooms, storage closets, and surgical rooms. Now, there is an exception for direct vent appliances or sealed combustion appliances, where they are bringing in dedicated outside air for combustion, passing it through the combustion chamber, and then discharging the exhaust back outside. So it does make sense that we would not want to locate, you know, gas-fired appliances or solid fuel-fired appliances, you know, in sleeping rooms and bathrooms. Storage closets may be a more common application, and it may also be able to be done. However, it does have some additional requirements in order to be eligible. Again, talking about heating and cooling calculations, here the IMC calls out that system design shall be determined in accordance with ASHRAE Standard 183. ASHRAE publishes several different standards, which is something a little different than a code. And then this also references back to design parameters specified in Chapter 3 of the IECC. So here, where I noted earlier about the codes making reference back and forth to other standards and codes, rather than calling out and re-specifying all the design parameters. Here they're letting ASHRAE provide that design procedure, and then the IECC providing design parameters for it. The other side is ventilation required. So here, any occupied space must be ventilated either via natural means or mechanical means. And they also further go on to specify that if an infiltration rate in a dwelling unit is less than 5 air changes per hour, then the dwelling unit shall be ventilated by mechanical means. Now this is a little bit unique in that for R402.4.1.2, the air change requirements are between 3 and 5, depending on which climate zone you are in. And even in the Illinois energy code, it requires the air changes to be less than 5. So here it may seem a little strange that they specify that the infiltration rate less than 5 requiring mechanical means, and one might imagine that or would anticipate that the IMC would just say mechanical ventilation is required. This building may be being done under a performance method and have a specified air infiltration rate higher than 5 air changes per hour. So that's where this little caveat of if you are less than 5, then you are required to use mechanical ventilation. As far as if we are in the International Mechanical Code, this is for larger than single-family homes. But here they require some new additions in the 2018 code. And this is for system controls, where we must provide system controls for outdoor air ventilation systems, or where those controls are provided, then they have to be labeled with a text or symbol to show the system's function. This is something where if you don't have a label on the controls, then the occupant may not necessarily know what this is for and may end up turning them off. So if an occupant was to turn a system off without necessarily knowing what they are, could increase the accumulation of harmful pollutants without their knowledge. Many people have heard the term, you need your house to breathe. And here, because of more modern construction methods, we are building better and better and tighter homes. And so making sure that we do have the proper air exchange between the inside and outside. So, and it also, another new requirement is making sure that the exhaust equipment that's serving an individual unit is listed and labeled to provide the minimum airflow. Doesn't necessarily require this to be tested in place, but that they must have been tested, listed, and labeled to make sure that, if we're putting in a fan of a specific size, that it has actually been tested to be able to provide that air transfer rate. So this is a look at what some controls could be. The picture on the left is a simple on-off control, and the picture on the right is more of a programmable control. These programmable controls may include things such as a CO2 sensor to try to monitor the indoor air quality and provide appropriate ventilation. So if you were to have a gathering with several people in a home, that the system would see the increased occupant loading of a pollutant and increase the speed of the ventilation system to provide more ventilation for the higher occupant load. Another area that the IBC talks about is looking at enclosed parking garages. And for single and two family dwellings, there is an exemption for some of the parking garage ventilation requirements, but for larger buildings that you have to have a ventilation system and again here the International Building Code is referencing chapters 4 and 5 of the International Mechanical Code. So again, another cross-reference between codes. So if we switch over to the International Mechanical Code, here they've consolidated the two requirements from the 2015 version into a single requirement in the 2018 version. Here, the text calls out, a full capacity airflow rate of not less than 3/4 of a CFM per square foot of floor area served, continuous, or it can be cycled between that high airflow rate and a lower airflow rate of not less than 0.05 CFM per square foot of floor area. And here using carbon monoxide and NO2 sensors to determine when it needs to switch between the lower airflow rate and a higher exhaust rate. Now this will come into play here a little bit later when we talk about energy recovery, because this is now a continuous exhaust. If you have a conditioned, if you are in a conditioned parking garage, energy recovery may begin to be required here too. But this fairly low minimum airflow rate, 200 CFM fan could provide up to 4,000 square feet of floor area, and this low minimum ventilation rate. So,
yeah, okay. So the IMC, the International Mechanical Code, although there's probably not a lot of this out there, we figured we'd bring it to your attention, stationary battery storage systems. We will probably be seeing more of this in the future with our buildings getting greener and people actually wanting to go off grid and store some energy on site, possibly with PV systems. So there have been, one of the changes in this section in 502.4 was that in the 2015 IMC, the lithium batteries, there was an exception for those for ventilation that has been gotten rid of. Those spaces now with lithium batteries do have to be ventilated. And you can see number 2 there, the title of the text for 502.4.1 is changed from hydrogen limits in rooms to flammability limits in rooms, recognizing that we really don't know what certain building battery technologies are going to be coming about, and emissions from those could very well be flammable. So that changed to be more generic rather than specific to just hydrogen. And before there was, you could possibly bring those ventilation in those rooms with battery storage down to 0. Now that's not possible. It's been expanded to require not less than 150 CFM. So I suspect that over time that these types of sections of the code will be changing as these technologies mature. The 502.5 is ventilation of battery systems in cabinets. As you can see, the former title was valve regulated lead acid batteries in cabinets. Once again, there's a lot more than just lead acid batteries out there. So this recognizes the new title. It just says ventilation of battery systems. So no matter what kind of batteries. And the 3 subsections that were under 502.5 have now been eliminated, and it just references back to 502.4. So simplification of this this area in the code too. Repair garages for vehicles fueled by lighter than air fuels. It's our vehicle technology is changing too. You can see that the former title was repair garage for natural gas and hydrogen fueled vehicles, and now it's more generic repair garages for vehicles fueled by lighter than air fuels. And the text and exemptions under those have also changed. We'd just like to bring that to your attention. One change in the 504 clothes dryer exhaust. It's a new addition to the 2018 IMC exhaust termination outlet and passageway size. The minimum opening area of 12.5 square inches is equivalent to the area of a 4-inch round duct. Nothing's changed to how long the duct can be from the fan to the terminus or the terminal, but the terminal you cannot downsize at the roof jack or wall vent. You have to have at least the equivalent of 4-inch round duct there. It's interesting because the testing of common roof vents disclosed that the back pressures provided by some of these roof caps or wall vents was equal to, some of them were equal to 3 and 3.5 elbows. So they provided a fair amount of significant back pressure. So the code recognized this, and to hopefully maintain good ventilation for these or exhaust for clothes dryers, they've addressed at least the terminal end, but like I said, they did not address the length of the pipe that connects the fan to the terminus. That's an improvement on the code. Domestic cooking exhaust equipment. This section has been renumbered, and additional compliance with UL and ANSI standards have been incorporated in the code. So as you can see, the following 4 points, these are all new to the 2018 IMC. I suspect that it's really not going to change any of your design practices, but they've just expanded this section to these to include these UL and ANSI requirements or standards. It's just a little more detailed.
As we move from exhaust requirements, now we're moving into energy recovery of exhaust and ventilation. So here the IMC is noting, where we're required for energy conservation, again, comply with the IECC. So again, more of these cross-references here. And the 2015 has been, or the section has moved from the 2015 IECC to the 2018 IECC. Again, some more of this maneuvering, renumbering, labeling, trying to provide a little bit more of a intuitive or process flow to the code, and trying to get better usability on it. So as far as when energy recovery is required, so for systems that operate less than 8,000 hours per year, there is one set of criteria. And when you get into over 8,000 hours per year, there is another set of requirements. Here in the state of Illinois, we're in zones 4A and 5A. And so with those, if you see that we've got a airflow rate of greater than just 40 CFM that operates continuously year-round, once you're over 40, then you have to do energy recovery. Now this is for conditioned spaces. If you recall earlier when we had talked about enclosing parking garages, this is where this can really get challenging. Is, if you're enclosing a parking garage, you are likely going to be required to do energy recovery for that ventilation if you are going to condition that parking garage. So this is one area where the 2018 code has become slightly less restrictive than the 2015 code. In the 2015 code, these numbers were 0 for over 8,000 hours per year. You had to do energy recovery with your first CFM. So here you're now allowed at least some before you have to do energy recovery, but still these are very restrictive limits. Anytime you have underground ducts, you have to be sealed and tested prior to placing them, encasing them in concrete or direct burying them. And so again here, another cross-reference back to the IECC and testing them for leakage via the section C403 protocol in the IECC. IMC, the International Mechanical Code, also calls out that you have to insulate the ducts, and duct insulation shall conform to the requirements found back in C604.2 through 604.13. I believe that's a typo here, because that should be 404.2 through 404.13. Because section 6 would be chapter 6. That's not in that section. As far as the, there's a lot of new stuff coming to the IMC, specifically for safety and relief valves, making sure that, because these are safety and pressure relief valves, making sure that they're discharging in a safe manner. So these are 13 new points to it. Won't read them all to you, but there's a major, this is a very large change, again, specifically related to safety here in the IMC 1006.6 for safety valves. A lot of these are similar to other requirements that have been there in the past. Looking at here, number 10, terminating not more than 6 inches above the floor. So thinking of a hot water tank with its temperature and pressure relief valve, making sure that we pipe that down near the floor so you don't end up with spraying hot water and potential burns in case the valve released with someone nearby. So definitely trying to make sure to ensure more safety. Pipe insulation thickness. The IMC requires reference back to the IECC as far as requiring pipe insulation of appropriate thickness. Now, here you see that this is the table from the IECC and showing the minimum thickness per the code. Now, I do want to call out that this is not necessarily the most cost-effective insulation thickness, and it may be cost-effective to exceed these thicknesses. That is something I would encourage if you have some large institutions, it would be recommended to actually go through the economics and develop your own pipe insulation thickness table based on what is cost-effective for your site, given your prices for energy and system efficiency, and develop a table like this for any large institution or an entity that may have several sites. It may be beneficial to put together to determine what's your cost-effective insulation. Pipe insulation is one of those great opportunities where this is something that you install insulation and it will quietly do its job for the next 20 years, as long as it's not in an area where it's likely to get damaged. So spending a little bit going a little beyond the required minimum may have a very good payback for you. IMC calls out that have to have a thermal barrier for slab on grade and suspended floor, and calling out that it be done to the IECC. Specifically here, the importance is making sure that we're providing a thermal break between the interior and exterior environment, or the ground in the interior environment. Insulating to 6 inches is not necessarily as critical as making sure that you're providing that first inch of insulation to make sure that you get that thermal break. And here in the illustration, you can see the Department of Energy has come out with several different illustrations as far as how you might meet that requirement. So the IMC Chapter 14 Solar Thermal has been greatly expanded. Previously, it was called just installation, and now for the 2018 version, they're calling it design and installation. So as you can imagine, that the 2 little words of design and really greatly expanded the scope of this chapter. But we're not going to necessarily discuss that in this presentation. But wanted you to be aware of some of these more major expansions of the code. What the IMC does cover is calling out that the piping does need to be insulated. Again, going back to the IECC to determine what that insulation requirements are, and that here we have an exterior insulation, that we make sure that we are protecting it not only from physical damage but from degradation, because ultraviolet rays are extremely can be very damaging to a lot of different materials. And so if we're placing a material outside, making sure that we are designing and installing that equipment that is designed for that harsh UV environment. So wanted to remind everyone of the question and answer panel that is available to you. So if you do have any questions, feel free to use that. If you do think of questions after today's presentation, feel free to reach out to us again at energycode@sedac.org. And we do have some questions regarding the implementation of the Illinois Energy Code. Assuming that the adoption is on June 1st, the effective date is anticipated to also be June 1st. So any designs submitted for permitting on or after June 1st is required to be adhering to the new 2018 IECC. The 6 months later was actually from 6 months from back in September of 2018. So the 6-month clock actually started back in 2018. So that 6-month clock will have already elapsed, but the effective date should be June 1st of 2019, at least as of today's recording. Again, please check our website, sedac.org, for more updates as things proceed. And as information becomes available, we will make sure to post updates to our website here. Give another minute here to see. Do want to give a reminder that we do have an upcoming workshop, or 2 workshops coming up here next week, April 30th, here in Champaign, Illinois. One of these is on residential, the residential provisions of the IECC, and the other one will be on the lighting, the commercial lighting provisions of the IECC. Also want to give a reminder of the next webinar will be May 22nd, again at noon, and the topic will be on existing buildings in the IECC. So I do want to have people mark their calendars down, again, April 30th in the morning and May 22nd at noon, upcoming opportunities. So with that, I want to thank everyone for attending today's webinar on behalf of myself and Robert. If you do have any other questions, feel free to reach out to us, energycode@sedac.org. With that, I want to wish everyone a great rest of your day, and we look forward to seeing you next month. Thank you.